is benefited to learn about renewable energy. Sunlight, wind and water are examples of naturally supplied sources of renewable energy. These sources are broadly accessible, non-polluting and sustainable in contrast to fossil fuels. To mitigate climate change, lower carbon emissions and increase energy security by lowering dependency on fossil fuels, it is necessary to learn about renewable energy. By encouraging innovation and creating jobs in the RE sector, it promotes economic growth. RE is an essential component of an environmentally friendly future because of its long-term sustainability and lower operating costs. Next, why we choose wave energy technology. Wave energy has been chosen because of its great potential and efficiency. It uses the wind-driven movement of ocean wave across the surface of ocean to create power. Wave energy is particularly well suited for coastal areas and is utilized for water desalination, fluid pumping and power generation, all of which support sustainable development. Wave energy is the most abundant ocean energy source worldwide. According to Ocean Energy Article 2024, its significant importance in sustainable energy solution is proven by its installed capacity, which reached 494 megawatts by the year 2024. Wave energy devices are more efficient than wind or solar power because of its high energy density, which is 800 times greater than that of air. They can generate up to 30 kilowatts per square meter. So how does this energy source work? The source of wave energy is wind, which transfers energy to the ocean surface to create wave with both potential and kinetic energy. This energy is captured by devices like oscillating water columns, point absorbers, and floating buoys. This device follows the wave, utilizing integrated generators to transform motion into mechanical energy, and following that, electrical energy. The height, speed, length, and density of the waters are used to measure the energy of waves. More electricity is produced by stronger wave. Throughout the year, wave energy offers a steady power output that complements other renewable sources for an optimum supply of energy, since wave patterns are more reliable and consistent than solar or wind circumstances.
Are the main components and steps in generating energy from wave. So wave energy comes from the natural movement of ocean wave, which move up and down due to the wind and tides. To collect this energy, we use a device called wave energy converters. So this device can be placed on the surface water, partially underwater, or fixed to the ocean floor, depending on the design and location. So point absorbers are one common type. There are floating buoys that move with the wave, and the motion is used to generate energy. Next, oscillating water column use the rise and fall of water inside the chamber to push air in and out. The moving air spins a turbine to produce electricity. Overtopping device collect water as wave crash over them. The water is then released through turbines similar to how a dam works. The basic steps including capturing the wave motion, converting it into mechanical energy, and then using the energy to generate electricity or store it for future use. These steps help us make the most out of the ocean's energy in a clean and environmentally friendly way. So next, how wave energy is converted into electricity. After capturing the wave motion, the next step is to turn it into electricity. Different systems convert wave motion in different ways, depending on their design and location. In point absorbers, the movement powers parts like hydraulic pumps or generators. These parts may push fluid, spin gears, or move magnets to generate electricity. Linear generators directly convert the motion into electricity using magnets and cords. In oscillating water columns, wave movement pushes air through a turbine. The turbine spins and drives the generators to produce electricity. Electricity is then sent to shore through underwater cable. The method depends on wave conditions, cost, and system reliability. The goal is to create stable and usable power from the ocean natural motion.
Hi, today I would like to talk about environmental and economic impact. Imagine clean energy with zero pollution. That's wave energy. It doesn't release any carbon gases, so it's a fantastic way to fight against climate change. These devices are most likely submerged under the water, so they don't spoil our beautiful coastal views, unlike big wind turbines. Plus, they also produce minimal noise pollution, very beneficial for us, not? Believe it or not, these wave devices can even protect our lines from strong waves, especially during monsoon seasons, helping our beaches and ecosystem. Fun, right? Every new technology has its quirks. For wave energy, we need to think about our marine friends. Installing these devices means putting foundation and cables on the seabed, which can be a bit noisy and creates electromagnetic fields. We need to carefully not to disturb ocean life too much. Also, because they're designed to be low profile and tough, wave energy devices can be hard for boats and marine animals to spot. Safety is super important, so we need to carefully plan it. And like any new techs, it's still quite expensive to build and maintain right now. We're still learning and all the long-term impacts as more projects gets off the ground. Let's be honest, wave energy is a bit pricier compared to more established renewable like solar and wind. Building these devices can cost anywhere from 3,000 USD to 8,000 USD per kilowatt. And keeping them running, that's also quite high, potentially around 0.07 per kilowatt hour annually, or even up to 328.10 cents per kilowatt in fixed costs. But remember, it's a developing technology. As we learn more and build more, these costs are likely to come down. Think of how much solar panels cost when they came out. Wave energy is a fascinating and powerful renewable source with huge potential. While there are challenges, especially with initial costs and ensuring marine safety, the environmental benefits are clear, clean, and greenhouse gas-free power. We're still in the early stages, but with ongoing research and development, wave energy could play a big role in a cleaner, more sustainable future for places like Malaysia with our long coastlines. Thank you.
Okay, next I will explain about the future potential of wave energy. So for the first part is for the advancement or innovation. So nowadays there is improved device design, just as focusing on efficient, scalable and modular wave energy converter, and utilizing durable, corrosion-resistant material and exploring multi-functional platform. Next is optimized power system, so innovating power takeoff (PTO) system for maximum energy capture, and this include direct drive generator for simpler power trains and advanced control system for dynamic adjustment to wave condition. And last one is hybrid energy solution, combining with energy with other renewables like offshore wind for consistent output, and researching energy storage such as batteries and also hydrogen cell to manage intermittency and ensure reliable power. Okay, next I will explain about our opinion towards the widespread of wave energy. So we agree that wave energy will be widely used in future as expected due to the predictability, versatility and anticipated technology maturity. And for the predictable and abundant, wave energy are highly predictable, adding grid integration and have high energy density. Technology maturation, ongoing investment in device, PTO and hybrid solutions are improving availability, investment with lower cost LCOE and established standard leading to commercial scale and competitiveness. And last one, dual use potential integration with coastal protection such as harbor walls, offer shared costs and environmental benefits.